Artificial intelligence is rapidly evolving. We see its power all around us. Current AI, often built on neural networks, learns from vast amounts of data. It can identify patterns, it can make predictions, it drives our search engines, it powers recommendation systems. However, this AI has its own set of challenges. It often operates like a black box. We see the input, we see the output, but the reasoning process in between can be very obscure. This lack of transparency is a significant hurdle we must overcome for true progress. The universe of computing is also expanding into the quantum realm. Quantum computers promise incredible processing power. They can tackle problems impossible for today's supercomputers. Think of simulating complex molecules or optimizing global logistics. Yet, quantum systems alone also have limitations. They excel at specific tasks, but general reasoning and understanding context are not their primary strengths. Building truly intelligent and adaptable systems requires more than just raw computational speed. We need a new approach, a synthesis of different strengths for a more robust AI. This brings us to a critical juncture. We need AI that is not only powerful but also understandable. We need AI that is not only fast but also aligned with human values. The demand for explainable AI, XAI, is growing louder every day. Users, developers, and regulators all want to know an AI reaches its conclusions. This is crucial for trust. It is essential for accountability. Ethical considerations must be woven into the very fabric of AI development from the outset, not as an afterthought. The future calls for a smarter, more transparent form of artificial intelligence. This is where the groundbreaking concept of GLCND emerges. GLCND stands for a vision integrating the computational might of quantum systems with the clarity of symbolic reasoning. Symbolic logic provides a framework for representing knowledge and rules explicitly. It allows for step-by-step deduction. It offers a clear path of reasoning. Imagine combining this with quantum speed. This fusion aims to create AI that is both incredibly capable and deeply scrutable, paving the way for innovations we can truly trust. So, what exactly is this GLCND, this fusion of quantum power and symbolic logic? Think of it like this. Neural networks are fantastic at pattern recognition. They learn implicitly, like a child learning to ride a bicycle through trial and error. Symbolic AI, on the other hand, works more like an adult following a detailed instruction manual. It uses explicit rules and logical steps. Each approach has its own distinct advantages. Neural networks can handle messy, real-world data. Symbolic systems offer clarity and explainability. Now, let's introduce the quantum element. Quantum computing operates on principles that are quite different from classical computers. It uses qubits, which can represent a 0, a 1, or a combination of both through superposition. This allows quantum computers to explore many possibilities simultaneously. This capability offers an exponential speed-up for certain types of complex calculations. However, harnessing this power for general AI tasks requires a guiding framework. Purely quantum algorithms might find an answer quickly, but explaining that answer was found can still be a challenge. This is where symbolic quantum reasoning, the core of GLCND, truly shines. It proposes a partnership. The symbolic component provides the high-level reasoning structure. It defines the problem space. It sets out the logical rules and constraints. It maintains a knowledge base that is human-readable and verifiable. This structure guides the quantum component. The quantum processor then uses its incredible speed to search through vast solution spaces defined by these symbolic rules. It rapidly evaluates possibilities that would take classical computers eons. The benefits of this synergistic approach are immense and multifaceted. GLCND offers a pathway to AI systems that are not only exceptionally powerful, but also inherently more explainable. Because the symbolic framework underpins the operations, the reasoning process can be audited. We can trace the logical steps. We can understand why a particular decision was made. This addresses the black box problem head-on. It also allows for the explicit encoding of ethical guidelines and safety constraints directly into the AI's operational logic, making AI safer and more aligned with societal values. The potential applications of GLCND are as vast as the cosmos itself. Consider the field of biotechnology and pharmaceutical research. Discovering new drugs and therapies is an incredibly complex process. It involves sifting through massive data sets of molecular interactions. GLCND could accelerate this dramatically. The quantum component could simulate molecular behaviors with unprecedented accuracy. The symbolic component could guide this search based on existing biological knowledge and desired therapeutic outcomes. This could lead to faster breakthroughs in personalized medicine and disease treatment, saving countless lives. Then there is the critical domain of cybersecurity. As quantum computers become more powerful, they pose a threat to current encryption standards. We need new forms of security, quantum-resistant cryptography. Developing and stress testing these new cryptographic methods is a monumental task. GLCND could be instrumental here. It could help design robust, quantum-resistant algorithms. It could also power advanced threat detection systems, capable of identifying and neutralizing sophisticated cyber attacks in real time by reasoning about novel attack patterns, not just matching known signatures. This ensures our digital world remains secure. Macroeconomic modeling is another area ripe for transformation. Economies are complex adaptive systems. They are influenced by countless interacting variables. Predicting economic trends or the impact of policy changes is notoriously difficult. Current models often simplify reality too much. GLCND could allow for far more sophisticated and nuanced economic simulations. It could incorporate a wider range of data. It could model complex feedback loops more accurately. This would provide policymakers with better tools to foster economic stability and growth, potentially mitigating financial crises. And let's not forget the final frontier: space exploration and infrastructure. Managing complex space missions, designing sustainable off-world habitats, or optimizing resource utilization on Mars requires immense planning and problem-solving. GLCND could design more efficient spacecraft trajectories. It could manage autonomous robotic systems for construction and maintenance in harsh environments. It could even help us analyze vast amounts of astronomical data to uncover the secrets of the universe. The dream of a multiplanetary species becomes more attainable with such advanced AI guiding our endeavors. The development of GLCND isn't just a technological leap, it's a societal one. Scientists stand to gain immensely. They will have tools to tackle previously intractable problems. Imagine chemists designing new materials atom by atom, or climate scientists modeling Earth's systems with far greater precision. The ability to combine massive computational power with explainable, logical frameworks will accelerate discovery across all scientific disciplines. This means faster progress, deeper understanding, and more innovative solutions to global challenges. The universe of knowledge expands. Policymakers and governments will also find GLCND invaluable. Crafting effective legislation and public policy requires a clear understanding of complex systems and potential consequences. Explainable AI, like that promised by GLCND, can provide transparent justifications for its recommendations. This allows for better informed decision-making in areas from urban planning to public health. It fosters trust between citizens and governing bodies. It ensures that AI tools serve the public good in an accountable manner, strengthening democratic processes. For developers and engineers, GLCND opens up a new frontier of AI creation. They will be empowered to build systems that are not only more capable but also more reliable and trustworthy. The symbolic component allows for easier debugging and verification. It facilitates the incorporation of safety protocols and ethical guidelines directly into the AI's architecture. This means developers can innovate with greater confidence, knowing they are building systems that are robust and aligned with human intentions. The creative possibilities are truly exciting. Ultimately, the greatest beneficiary of an ethical, explainable AI like GLCND is the general public. We all stand to gain from medical breakthroughs, enhanced security, a more stable economy, and sustainable technological progress. An AI that we can understand and trust is an AI that can be integrated more seamlessly and beneficially into our daily lives. However, this future requires a conscious choice. We must prioritize a balanced approach, where the relentless pursuit of computational power is always matched by an unwavering commitment to transparency, ethics, and human oversight. The cosmos awaits our wise choices.